Next we have Shuichi Ihara from DataDirect. He's been working for DDN in Japan for 3 years as Senior Solution Architect. Before joining DDN, he worked in Sun Microsystems' Lustre engineering team, developing HPC software stack. Ihara is now in charge of DDN's worldwide benchmarking system and works on a lot of Lustre benchmarking, optimization, building Lustre-based solutions. Ihara, it's all you.
Thank you. I'm Shuichi Ihara, DataDirect Networks Japan. Today I talk about the active-active LNET bonding using the multiple LNET and Infiniband partition. Let's get started from today's raster hardware trend for raster. The server side, the powerful server platforms emerging. So we usually have the 16 CPU core on the server. It's the number of the CPU's core is growing, and also we have the high memory bandwidth, the PCI and the bus bandwidth. Then when we calculate the raster performance, so number of the OS is a very important factor in order to obtain the high performance throughput. But when number of the OSs is increased, the power or management cost is also very critical. Disk side, so we are the first drive. We are moving for new 2.5-inch, the form factor, 12 Gbps, a new SAS and the PCI, the device connector is coming. Of course, this is very new, but the price for high-speed drives is decreasing rapidly. Infiniband is one of the good options for high bandwidth to the storage as the host interface. And Infiniband is very common for the interconnect for raster network today. The short conclusion, the performance of all of the hardware components, the performance is very increasing drastically. But the challenge is achieving the optimal hardware software performance. Today's the topic is raster network driver and the raster network, the performance and bonding. Today's our raster network, we are getting the 6 GB per sec on the Infiniband QDR links. Of course, we have the more bandwidth. If we could get the more bandwidth, it's very helpful if the storage performance is more powerful, or if we want the number of if we want to reduce the number of the OSS server. The channel bonding, there are several discussion on the raster history, but at this moment, our raster network driver for Infiniband, active channel bonding is not supported yet in the raster mainstream. We have several options for Infiniband. Infiniband, the multi-rail configuration is supported since the raster 1.6. Raster also support raster network driver for Infiniband is supported. It supports the active, the standby, the configuration. This is a more detail about the active standby Infiniband configuration. So raster OSs usually have the 2 HCA for redundancy. It's running the active standby mode. Then we have to create the bond interface using the 2 interface. Then we also have to create the raster network with the Infiniband network driver using the bond interface for IP over IP. So the client access, so when client access the OST, so client use the active path, but once the active path is failed by the hardware reason, so the bonding driver to try to the failover to select the slave interface. Then once the failover is complete, the raster server is reconnect to the client, then I/O back to the again. So this is a failover capability, but no performance advantage. The multi-layer configuration, this is a hardware, it's just pretty same, the hardware, but we have to create we have to divide the two raster network, and also we have to create the two network client group to access the raster file system through the raster network 1 or raster network 2. Server perspective, it's running the active mode, but then we can get the twice the aggregate bandwidth on the server side, but this is no failover capability. So our new approach is integrating the active multi-layer configuration with the active standby to making the active the LNET configuration. So it's kind of the the active standby makes active configuration. So in order to make this configuration, we used the IB partitioning to make Infiniband child interface. Then we also have to the multiple the bonding interface on the server side. Then it's also running the active standby mode. So we have the multiple the bonding interface for throughput. Then we also the raster also provides the active standby failover capability for them. So what is the advantage? We don't need any the raster modification for them. Just IB partitioning configuration, and also the extra bonding and LNET configuration. Of course, we don't need any additional hardware on the client and the server, but if we want the more increased performance, so the additional hardware is help. Since raster 2.3, we have the CPU affinity setting for LNET. So the previous session mentioned there the big NUMA aware configuration is help for OST access. This configuration supports the auto failover and failback configuration, as well as the user control. The IB link control is possible. So what is a Infiniband partition? This is one of the future of Infiniband to isolate among the system the sharing the Infiniband fabric. Its idea is very similar to the VLAN on TCP/IP. It's enforced on the host side and the switch side. The partitioning are represented by P key. It's kind of the VLAN ID. Subnet manager creates the P key and manage the table for HCA and switch in the network. So there is a two membership configuration mode. So one is a full access. So all of the membership, the member can talk to another partition member. This is a full access. The limited access, so the limited access member cannot talk to another partition member. So in this configuration, we only use the full access mode because we don't need any restrict the group. Just wanted making the child interface for IP over IB. So this is a more in detail the active LNET configuration. This is the same hardware we are using the multi-layer configuration or active standby configuration. But we create the 2P key on the Infiniband. They're making the two child interface for IP over IB. Then we also create the two bond interface to associate the 2P key. So for example, the bond interface 0, so associate the P key 8001, bond interface 1, to associate the P key the 8002. Then finally, so we create the LNET with the Infiniband network, raster Infiniband network driver using the bond interface for IP over IB. The client side, it's also have to create the child interface on the one HCA to access to raster network. The OST size, they have the restrict access for each network to make a optimal the I/O path from the client to the OST. So I will talk about more detail next. So this is a OST configuration. So we create the one single file system consist with all of the OST, but the even number OST is only accessible from the net. So LNET 0, which is O2IB 0. And odd number OST, it's only accessible from the LNET 1. So when client access to all of the OST, the server side, the client sends the RPC on the both networking, then server receiving all of the packet from the to both HCA, then sending the OST. So both HCA is running on the active. So we run some benchmarking on this configuration. This is simple test configuration. So we use the DDN, the SFP 12K40, 160, the 15K SAS drives. We just set up the two raster server. One is MDS, another one OSS. Then two FDR Infiniband card install per server. Then client, we had the 16 client. It's a standard Sunday Bridge server. Then QDR, the Infiniband HCA install. So we tested the raster master branch on the CentOS 6.3. This is a benchmark number. This is a single OSS throughput number for write and read. So there is a 3 configuration. So one is no bonding configuration, which is a light blue color. Then the bonding configuration without a CPU binding, which is a light red color. Then finally we tested also the active CPU binding. It's a green bar. So you can see we are getting the around 6 GB per sec without the InfiniBand bonding, but we cannot see the performance improvement on this configuration. But active configuration, now finally we got the 9.5 GB per sec for write, or 11 GB per sec for read. So it's pretty high number compared to the single FDR link performance. Then we didn't much see a performance difference between the CPU binding and not CPU binding. And also the write performance are a little bit lower than the read performance. So we added we enhanced the hardware configuration to adding 2 HCA for dedicated storage network. So finally, we use the 4 HCA, the 2 HCA for 2 network for the raster network, 2 HCA for storage network. There is no other the configuration change on the server hardware side and the software side. Then we run the IOR again. Then finally we got the write performance improvement. So finally we got the 11.3 GB per sec for write, 11 gigabyte per second for read. So read performance is the pretty same compared to the 2 HCA configuration, but we got the improvement on the 4 HCA configuration for write. This is a 1.8 times faster compared to the 1 FDR link configuration. And also the number is pretty close of the 6.4, 94% of the 2 LNET maximum bandwidth, which is a quite nice number. This is the another testing, the failover testing. So we ran the IOR job, but during the IOR, so I removed the one FDR cable for LNET. So of course, one cable is removed. Once one cable is removed, so half of the OST is not accessible, and it's stuck on the client. Then the bonding interface try to the failover. Then once the bonding interface select a new slave interface, then bonding interface is complete, the failover is complete, the raster try to reconnect to the client. Then once the reconnect is complete, so all of the OST is accessible on the from the client, but it's running the 1 HCA as a regression mode. I installed the FDR cable back again, then bond interface try to fail back. Then once failback is complete, so raster try to reconnect again. Then finally the raster reconnected is complete, so the performance is back again. Then all of OST is accessible on the both HCA. So this is the failover testing. So the previous testing is the auto failover and auto failback. So this is the administrator control the active link change. So the bond interface, basically the part of the Linux, the standard Linux utility. So they have the one user space utility, so which is the IFN thread. So it can help to switch the active link interface. So once we change the active link by administrator control, so raster try to reconnect. Once the failover is complete, so raster reconnect to the client, then failover is complete. So the conclusion, we demonstrate the raster LNET active configuration. This is not raster network driver channel bonding, but it's a raster network active configuration using the IB partitioning. So performance is good. We got the finally 11.3 gigabyte per second for write and 11 gigabyte per second for read. And the auto failback works well, and the user control failover is also works well. So one of the good use case. So if application really wants the bandwidth, so we can use this configuration on the client side to get the more bandwidth for the application. So this is not tested yet, but one of the good use case for this configuration. Thank you.